I hope you enjoyed and learned a lot from today's talks. I'm really excited about the integration of Qualys into Spark to make data science scale much easier. The adoption of MLflow is really impressive. It's great to see the work that the community keeps putting into the project. Great new features in Databricks ML with AutoML and Feature Store. It is now my pleasure to introduce our next guest speaker. Bill Nye is popularly known as Bill Nye the Science Guy. He's an American mechanical engineer, science communicator, and television presenter. Following the success of his show, Nye continued to advocate for science, becoming the CEO of the Planetary Society and helping develop sundials for the Mars Exploration Rover missions. Please join me in welcoming Bill Nye to Data and AI Summit.
Greetings, Bill Nye here. Hello to everybody at the Data and AI Summit. It's great to see you all again. Wait, I can't see you, but you can see me. And that's good because we're using millions and millions. I would say certainly 10 million, but probably closer to 1 billion transistors to engage in transistor logic and have this fabulous interaction. So thank you all for including me. Now, for those unfamiliar with this kind of picture, this is a picture of the Earth, and it's where I've spent my whole life, down there someplace. And I just like to remind people, it's not out of focus. That's the Earth's atmosphere. And the atmosphere is extraordinarily thin. In many pictures from space, the atmosphere is so thin. How thin is it? You can't even see it. It looks, as the old saying goes, it's like a coating of varnish on a globe. But I spent a lot of time in the atmosphere and breathing it and carrying on. And my first job out of engineering school was at Boeing. And I worked on 747 airplanes. Don't worry, everybody, if you've ever been on a 747, I was very well supervised. It's a fantastic plane. You're very safe on a 747. All right, with that said, when I was there, there was a guy who was still around, who was a test pilot on the very first 707. In those days, it wasn't even called the 707 yet. That was a designation that came along later. That was the Dash 80. This one is when they first painted it, this picture when they first painted it. And you don't have to know too much about airplanes. Can you see there's two features about it that are cool. Do you see how long, how wide the wing is at the root, as it's called, of the wing? In those days, that was all that structure was needed to hold the nacelles, the engines. And then you see all those vanes, those are on there to create to promote the turbulent boundary layer, to make the air flowing over the wing do this, the molecules tumble, and it actually reduces drag in exactly the same way you reduce drag by putting dimples in golf balls. And so I spent a lot of time there, and there was a guy who was still around, who was the test pilot, whose name was Tex Johnston. And Tex Johnston, like many guys of that era, he had been a pilot in World War II. He affected this US accent that Chuck Yeager, the famous guy here in the States who broke the sound barrier in a rocket plane, the X-1. And Tex Johnston was a test pilot on this airliner. And he did a barrel roll with the airliner. He took this giant plane and rolled it over twice. And there's this famous picture taken by the flight engineer. This is back in the day when an airplane like that would have three people in the cockpit. Well, in those days, they were all men. In the cockpit, a pilot, co-pilot, what we now call first officer, captain and first officer, and then a flight engineer. And the flight engineer took this picture. This is the guy that would watch the fuel gauges and make sure they weren't messing up. But it's upside down. So Tex Johnston lands. And this is before mobile phones at every press conference and video of everything that ever happened. You know, this is a different era. But by all accounts, Boeing management says to Tex Johnston, I paraphrase, but Tex, what are you doing? This is our prototype. This is the only, be careful with this thing. He said, I'm selling airplanes. And then he's supposed to have said, one test is worth 1,000 expert opinions. And those are words to live by, my friends. One test is worth 1,000 expert opinions. You can't beat it. That you can claim you know what's going to happen, but to really find out what's going to happen is of tremendous value. And let me say, I am honored to be invited to speak at the Data and AI Summit, because you guys and gals are the future. You all are going to change the world. You all are going to respect the facts and make the world better than it is today. And so I really appreciate you including me. Now, I know many of you are not in the US and may not be familiar with my work, but I'm a mechanical engineer. I worked on this gizmo to suppress vibrations in the yoke, the steering wheel of the 747. That was cool. It's the kind of thing they give to a young guy. All right, when you're fresh out of school, you can still do this arcane sort of off in the corner math. And so that was cool. I had tremendous loyalty to Boeing for a long time. But when I was in college, people were just beginning to talk about, or university, people were just beginning to talk about climate change. And climate change, you could say these days, was discovered on Venus, the planet Venus, when James Hansen, who's still around and testified in front of the US Congress in 1988 about climate change, pointed out that the Venus is kept warm by carbon dioxide in the air, in the Venusian air. And it's happening here on Earth because humans are putting extra carbon dioxide in the air, not just in the air, but putting it in the air fast, extremely fast. And that's the problem. And then when I was in school, this famous astronomer, Carl Sagan, and another guy, Jim Pollock, had done this analysis that if you set off all the nuclear weapons in the world at the same time, you'd create this huge dust cloud that would shade the Earth for weeks and weeks or months and months. And then Walter and Luis Alvarez found the crater that almost certainly it was a result of the impact, which created a dust cloud so big. How big was it? Bigger than the Earth's diameter, that it finished off the ancient dinosaurs. They may have been, the ancient dinosaurs may have been having trouble with other atmospheric problems, but that impact is what did them in. Anyway, these three things came together for me in the 1980s and then in the 1990s. And I got very concerned about climate change. I got very concerned about science education. I got very concerned about engineering. And so you guys, I'm so old. How old are you? I'm so old. When I was in school, we had punch cards. When I worked at Sunstrand Data Control after Boeing on black boxes, which really are black to radiate heat, we had Fortran 7. Woo! Oh. Anyway, a lot has changed in the last few years, but the principles of data management and computing are the same, just that you all are able to have the machine learn from its mistakes in a way that we just could not do. So my awareness of climate change has been with me for decades. And just recently, entities that concern themselves with these problems, National Aeronautics and Space Administration here in the US, the Intergovernmental Panel on Climate Change at the United Nations and elsewhere, have realized that this year is almost, or it's tied for the hottest year on record. The hottest year on record was 2016, which was a hot year combined with an El Nino. And El Nino is this warming of the Pacific Ocean that its effects are well known, but its cause is still a mystery. Anyway, in the El Nino year, it was the hottest year on record. 2020 was almost exactly the same hotness, overall warmth, but without an El Nino. So the world's getting warmer and warmer, faster and faster. That's where you all come in. You are going to, dare I say it, change the world. And you're going to do it by doing more with less. So for those of you around the world who may or may not have heard of this thing, I claim there are 3 things you want to do for everybody on Earth. You want to provide clean water, renewably produced, reliable electricity, and access to the internet for everybody in the world. And in order to do that, when people talk about clean energy, we're talking about electricity. Electricity is magical. You can do amazing things when you have access to electricity. And so you can make toast for your breakfast, or you can have a conference like this, electronically engaging people all over the world. And so along this line, there's an organization here in the States and that works with people around the world called the Solutions Project. And they have done an analysis. And look, you guys, I'm not saying this analysis is perfect, but it's something to think about. They have done an analysis, starting with the United States, that you could provide clean energy to everybody in the US right now if you just decided to do it. You would have geothermal energy where possible, wind energy, solar energy, not shut down any existing nuclear power plants. But don't try to build any more because it takes too long to get them done. And you use a lot of concrete, and there's no place, nobody wants the waste. Even if you had a great idea of what to do with the waste, nobody wants it. And they have continued the analysis. They say that we'd get about almost 3 million jobs just to run all this new infrastructure. And, infrastructure is a big word right now in the US. But they claim you could do it around the world. Now, let's say they're off by a factor of 2 or 3. This would be a huge start. If we had 100% clean energy around the world, we would solve an enormous number of problems for a great many people. And everybody, the whole idea that this can't be done to me, is misguided. It just looks like it can be done from an engineering standpoint. Geothermal, wind, solar, new, better battery storage, and perhaps in the next 15 years even, or let's say 20 years, we will have something like fusion energy. And of course, it will come to the developed world first. There will be problems with it. But in the next 40 or 50 years, it's very reasonable for a change that could be doable. If that's possible, we could, dare I say it, change the world. And so along this line, there's something that's very important, that's even a bigger idea than clean water, renewable electricity, access to the internet. And that is raising the standard of living of women and girls. When you raise the standard of living of women and girls, everybody's life is better. Everybody's life is improved. When you have twice as many educated people in the world, you solve problems in new ways. Study after study has shown that the more diverse the team you have trying to solve a problem, the faster you get to a more satisfactory or better answer. So you guys, maybe you heard that. That's a truck outside the window because we're doing this electronically because we couldn't get together in Northern California in the US this year. There it goes. Carry on, you guys. Anyway, we're able to do this because you all have created this remarkable technology. Now, raising the standard of living of women and girls is not an easy task. If you know where to look, the family myth is that my great-grandmother is in this picture. This is in the United States, in Washington, D.C. I grew up in the city of Washington, D.C., in the city limits. And the family myth is that my great-grandmother, Sally, was a suffragist marching in this parade the same week, I guess 3 days or 2 days after her first grandchild had been born. And, and a lot of people, a lot of grandmothers get very engaged with grandchildren, but no, she was out marching in the suffragist parade. And that was, you guys, well over 100 years ago. Now that family myth was passed down to me, but I can tell you this for reals as an eyewitness. My mother marched in the Equal Rights Amendment parade here in the United States. where women wanted the rights to vote. And my friends, of course, these are citizens of the country, and so they should have the right to vote. And just for those of you into the details, the Equal Rights Amendment was brought up, especially in 1973 is when it really got going. And there's a rule here, law here in the United States. You got, if there's 50 states, 38 of them or 2/3 of them have to agree to it. Well, the Commonwealth of Virginia has agreed or ratified the Equal Rights Amendment, and it's number 38, but there's all these issues of, has it expired? Has it been there too long before enough states ratified it? Anyway, all that aside, the world is changing. Whether or not this Equal Rights Amendment here in the world's influential, technologically, nominally sophisticated society, the world's third most populous nation, whether or not that happens this year or next year, it will certainly happen in the coming decades. For me, in my part, I would like to happen this weekend, but it'll happen sooner or later. The world is changing, and that's exciting. The world's getting warmer and extraordinarily fast. Women are being empowered in a way they have not been in millennia. And we are all going to have to get used to changing. And that is your business. That's what you all are into. The future is open. You all build software, and now combinations of software and machines that learn from their experiences electronically, automatically, softwareically. And so you all are the future. And I very much hope you will take this responsibility very seriously so that you can change the world. Now, speaking of which, the same guy who co-wrote this computer program in 1980, Carl Sagan, through a remarkable series of happenstances, was my college professor for one class. And he started the Planetary Society. 1980, we are the world's largest non-governmental space interest organization, advancing space science and exploration so that people everywhere know the cosmos and our place within it. Then the elevator door closes. No, that's you. The Planetary Society, through another extraordinary set of happenstances. Not only did I take one course from this guy and join as a charter member in 1980, now I'm the CEO of the Planetary Society, and we work to get governments and people around the world to support space science and exploration, especially the exploration of planets. So you guys, we are living at this extraordinary time. The Perseverance rover just landed on Mars, and it's got 2 microphones on it. And I've been in meetings, you all, where I won't say with whom I was in these meetings, where people, oh, we don't need to put microphones on Mars. No, we know the composition of the Martian atmosphere. We know exactly what it would sound like. You don't even need to do that. That's a waste of time, waste of weight on the spacecraft. And, it's a waste of bandwidth for telemetry, sending information back to, you don't need to do that. Okay, we put those microphones on there. And last week, the Ingenuity rotorcraft, this helicopter, the tips of the blades go at about 0.6 Mach. A 747 can get up easily up to that speed. But on this extraordinarily thin atmosphere, this other world, and these scientists saw the dust move on the surface of Mars in a completely unexpected way, and they heard the sounds for the first time. And I claim the Planetary Society was instrumental, pun intended, on putting those instruments on Mars. We got a microphone on Mars in 1999, Mars Polar Lander, but it became Mars Polar Crasher when these retro rockets didn't fire with a software problem. The landing gear extended, the software thought, if I can use that expression, thought it'd hit the surface, but no, it was in mid-space and just barreled in. Anyway, Carl Sagan and the Planetary Society have changed my life. When you look at this image, it is a way of addressing these 2 questions we all ask. We all ask these questions. Where did we all come from? And are we alone in the cosmos? If you want to answer those questions, you have to explore space and you have to explore Mars. So those layers of the Kodiak Mesa, which is the tentative name for this feature on Mars, are sedimentary layers under a cap rock. That's how a mesa forms. This place used to be soaking wet. There used to be a gigantic body of water flowing through here. Are there fossilized microbes in those layers, what on Earth we call stromatolites? And in the background there, you guys, that's not like dust in the atmosphere. That's the wall of the Jezero crater. This enormous feature on Mars that may have signs of life because it was a delta of some ancient body or of water or river system on Mars. And you all will very likely be alive when this discovery is verified or set aside. This hypothesis is embraced or set aside. If we found evidence of life on another world, it would change this one. It would change the way every one of us feels about being a living thing in the cosmos. And I claim there's a great lesson to be learned from this. The exploration of planets is a metaphor or a way of thinking about exploration in general. If you stop looking up and out, what does that say about you? Whatever it is, it's not good. So that's why we advocate for the exploration of other planets, not just here in the United States. We are an international organization, 100 members in 130 countries around the world. Check us out. Carl Sagan in class also told us this story back in the disco era. Johann Kepler was looking at the night sky and he observed what the comet that nowadays we refer to as Comet Halley. You may have used the expression Halley's Comet. That's fine, but they found people from the Halley family. They prefer to say Halley. And now the astronomical tradition is to say Comet blank, Comet Halley. Kepler was looking at this thing and he realized there's something about sunlight that was creating these tails. There's the dust tail and the ion tail, these charged particles that stream behind a comet as the dirty snowball, as it's called, gets volatilized by sunlight. So he speculated in 1607, 400 years ago, that he said people will sail the cosmos the way we sail on the ocean. And indeed, Carl Sagan presented this idea to this very famous talk show host here in the United States, Johnny Carson, back in 1976, September of 1976. We'll build a spacecraft so big and shiny. How big and shiny would it be that sunlight would just push it through space without any mass exchange? In other words, it's not the solar wind. It's not the particles that will push this thing. It's photons, pure energy, no mass. And this has been speculated about since Kepler's time, verified in the 1920s, really, when relativity was discovered and the quantum was investigated. And he proposed this, he and his colleagues proposed this spacecraft to catch up with Comet Halley to be launched in 1980, catch it in 1986. Well, it didn't get built. The space station and International Space Station and the US space shuttle program superseded. And the Ariane, the rockets, European rockets and Japanese rockets, they were built in exchange for this mission. All right. The Planetary Society pursued this for years. We built the Cosmos 1 solar sail. It ended up in the Barents Sea, which is an area, if you're savvy about global ocean going navigation, it's part of the Arctic Ocean. It's an area. It just crashed. All right, well, 5 years ago, the Planetary Society managed to build Light Sail 1. I was on a very famous talk show here in the United States, The Late Show with Stephen Colbert, a guy who succeeded essentially Johnny Carson after decades, talking about our solar sail mission, which is absolutely derived from Carl Sagan and his colleagues' mission and Johann Kepler. And we got it to work, you guys. Light Sail 2 is flying right now. Light Sail 2, you can check us out at planetary.org and see where it is. And we proved that if you all are the sun and the microphone is the earth, we could come at you like this, twist in space, get a push, twist, get a push, and build orbital energy, even in the gravity environment near the earth, where making this maneuver is hard because of the inertia of this large spacecraft. For those of you who remember anything about your fundamental physics, I know you're all software guys, but it's still true. Physics is still, as we say, things happen for a reason. That reason's usually physics. All right. We built the spacecraft to prove this for space agencies around the world and private and public space exploring corporations, because this technology might enable us to take cargo to Mars for free. There's no rocket fuel kind of thing. So that was the intent. And along with that, we built these cameras in the spacecraft that are very high quality. They're made by a company here in the States called the Aerospace Corporation. And it took our engineers, men and women who are here in California mostly, but also at Georgia Tech. Georgia is a state in the US, and there's some people that work now and then when they have time in a community college in Hawaii. And they have messed with the software over the last 2 years, and they're able to get these extraordinary pictures. This was the launch. It was a light sail, it was a Falcon Heavy, a SpaceX Falcon Heavy. And, you know, that company is very pridefully led by this famous guy here in the States, Elon Musk. And they used boosters that had already been flown. They strapped them onto this thing, and they had 3 of these giant boosters, 27 engines. Your chest shakes, your hair shakes. Oh man, it was just amazing. And so we got the thing in orbit, and the software people over the last 2 years have been able to send down these fantastic pictures. And this is what astronauts of all nationalities refer to as the overview effect. When you see the Earth from space, it changes the way you feel about the Earth, and it changes the way you feel about living on the Earth. And you guys, what's happened over the last millennia, 100,000 years, instead of humans being controlled by nature, or what you might think of as everything not human, now humans, we are in charge of nature. We are running the show. This is the Nile River and a bit of the Suez Canal from our spacecraft. It changes the way you feel about being a living thing. Are we alone? Where did we come from? Where did we come from? Well, now we're running the Earth. We're in charge, and that's where you all are going to change the world. The key to the future is not to do less. It's not to not drive, not eat, not wash your clothes. The key to the future is doing more with less. And that's where software and machine learning and artificial intelligence, to me, are going to change the world. Now, here's a famous picture taken by the Cassini spacecraft. Cassini was a mathematician who predicted or showed where the gaps in the rings of Saturn would be. And he was right. And this picture was taken a few years ago, and it's amazing. There's Saturn. It's gorgeous. The sunlight coming from the south pole of Saturn. What we've learned about the weather on Saturn has affected or influenced our analysis of climate change here on Earth. And speaking of the Earth, this is not just a beautiful picture of Saturn. It's a picture of the Earth. For those of you unfamiliar with this, the Earth's right here. That's it. That's the whole thing. That's everybody. If we fly up here this way about 100,000 kilometers, there's the same picture. And Saturn would now be below us if we were in a spacecraft taking this picture. Do you see the Earth? It's right here. That's the Earth. That's everyone you've ever met. That's every fungus. It's every tree. It's every sea jelly. Carl Sagan was very eloquent about this too. You know, every emperor, everyone who tried to control a corner of this dot in space, they all lived here. They've all come and gone here. There's nobody coming to save us. If we mess up the environment to the point where many of us cannot have a quality of life that's suitable for carrying on our generations of people, it's our fault. This is it. This is where we make our stand. This is the Earth. This is our home. This is where artificial intelligence and the future being open to new ideas, this is where you all are going to, dare I say it, change the world. Thank you all very much for including me in this conference. You guys and gals, get out there and change the world for the better. Clean water, renewable electricity, access to the internet to raise the standard of living of women and girls as we run the show here on Earth and make it better for everyone. Thank you.